We present VisualChef, a mask-based image and painting model that generates visual aids in cooking scenarios. Cooking usually depends on following recipes step by step, but they often miss important details. Recipes often rely on ambiguous instructions like cook until golden brown or season to taste, leaving home cooks guessing and prone to errors. Adding to this frustration, many cooking resources are designed in idealized settings with professional tools and hard-to-find ingredients, which can alienate those with more basic setups or limited access. For instance, a recipe might call for a stand mixer while a home cook has only a whisk, or feature expensive ingredients that aren't easily available. These gaps make it harder to adapt and succeed in real-world kitchens. The challenge is even greater for robotic systems, which lack the intuition humans use to interpret vague directives like stir until thickened or chop finely, as these rely on subjective judgment rather than precise, measurable criteria. To address this, we propose VisualChef, a method for generating contextually relevant visual aids tailored to the cook's environment and progress in the recipe. VisualChef creates images illustrating both the performance of a cooking action and the expected outcome, ensuring compatibility with the user's setting. Given an input frame representing the current state of cooking and the next action specified by a recipe, we aim to generate the action frame that shows the moment of action execution and the final frame which represents the cooking state after the action is complete. Previous methods like GenHow and Lego rely on detailed textual descriptions and additional data annotations for fine-grained visual-textual alignment. In contrast, VisualChef uses mask-based visual grounding and object-centric inpainting to simplify alignment and enhance efficiency. We first develop a selection strategy for image triplets. We define the initial frame at the action start, the action frame at its midpoint to capture core activity, and the final frame at 90% of the action's duration to ensure visibility of relevant objects in the frame and to avoid seeing transitions to the next activities. We use an object detection model to filter out those image triplets where the initial frame does not include at least hands or any of the identified relevant objects, or where the action frame lacks visible hands. The VisualChef pipeline starts with an initial frame as input, paired with an action description. A vision language model is employed to identify relevant objects and classify them into three categories: core objects, objects that are essential to the action itself, such as carrot in this example; location objects, that describe the initial or final locations of the objects involved, such as cutting board; and functional objects, that serve a purpose in the action but do not move other objects, nor is their location important, such as knife and hand. Using the open vocabulary segmentation model, we generate the masks for these objects. Core objects are relocated in an additional step to their final location as needed. The generation phase involves two different inpainting modules based on stable diffusion, conditioned on different combinations of the masks for creating the action frame that reflects the step being performed and the final frame showing the status upon action completion. The output thus visualizes the progression of the cooking scenario in a realistic manner. We use 3 egocentric datasets for training and evaluation. We use 11,000 image triplets from the Ego 4D dataset that provides precondition, point of no return, and post-condition frame annotation. We use 3,000 image triplets from each of EGTEA Gaze Plus and Epic Kitchen's 100 where only action labels are available. We split them into 80% for training and 20% for testing. To evaluate the model, we report FID, PSNR, and SSAM scores, following standard evaluation protocols for generative models, and introduce a set of metrics based on clip similarity. We evaluate the model on the test set of each dataset for generating action and final frames. We compare our method with 4 state-of-the-art methods for action-conditioned image generation. Overall, VisualChef outperforms competitors in content relevance, establishing itself as a leading model in semantic metrics. Qualitative results verify the performance of VisualChef across 3 datasets, further highlighting VisualChef as the top-performing model. We presented VisualChef, a mask-based image and painting model that generates visual aids in cooking scenarios, given an initial frame and a specified action. We introduced a data curation pipeline that automatically extracts triplets of initial, action, and final state frames from egocentric videos with available action annotations. We evaluated VisualChef on 3 egocentric video datasets with both qualitative and quantitative results showing improvements over the state-of-the-art methods. Please refer to our paper for more details.